Could you see the screenshot?
Yeah, I'm seeing the screenshot on a already type.
Okay.
Start.
Okay.
Okay.
Okay. All right. Okay, so today I'm gonna start explain the chapter 8. So chapter 8 is the data wrangling. So actually in the previous chapter we actually tried to study about the basic attributes of the data frame in Python. Then now based on that understanding, we're gonna try to study a little bit further about how we can manipulating that data frame by itself, especially when we have more than two data frames in the Python, and then how we can try to processing those data frames. So in here it says about the join and combine and reshape, right? But the thing is, it actually has the two parts because the join and combine is kind of like a merge, like how we can merge those data set into one single big data set. And then reshape means kind of like, how we can try to transform, like a data transform, right? Let me erase this, like a transform, like a wide format to the long format, or long format to the wide format, right? Like a kind of a pivoting, pivot the table or data frame kind of thing. So, and also try to summarize kind of things. Then, so we're gonna start the merge, how we can merge the multiple data frame into the one single data set, into maybe merge. So in here, before we try to talking about how we can join the combine, we need to understand about what is called the hierarchical indexing. Hierarchical indexing is a kind of like if we have a multiple kind of a index level, because at the bottom in this example, in the row label, when you're looking at our row label, which is here, right? We have two different keys. One is the A, B, C, D, right? And then the other second key gonna be the 1, 2, 3, right? So we have more than two index labels. So this one, and also the A, B, C, D has the more hierarchy compared to the numeric row label, right? 1, 2, 3. So in this case, we actually call this kind of indexing is the hierarchical index. Okay, like this. And then when we try to type the index method, we will see that these are the kind of a pair of the indexing labels. So, and also it says about the multiple index. With the A is a much higher level, like a key one. Key one is the A, B, C, D, which is a much higher level. And then key two is the 1, 2, 3 kind of things. And then this one is a much kind of a low level. So it has a hierarchy. So this one is what is called a multi-index or hierarchical index. And then we can also try to extract the data set by using what is called a partial indexing. So for example, when we try to do the B in the data, it only shows about the B value. Like B is actually has a 1 and 3 as a key, 1 and 2. So we can get that B value under the B category. And then the B and C is we can get the B and C, right? It's a simple. So, and then next one is also the same. Like we can, by using the location index, like a B and D, like this kind of indexing, we can also reading the value belonging to the B and D respectively, right? So And also kind of an inner level, like a lower level can be possible to use. So like here, so what this one means is we can call the A, B, C, D in the first key, right? And then the second key, we only have a column label 2. So that's the value like this. So this one is actually key 2, kind of indexing value. So everything in the first value, first level, but we only need the second row label with a 2 in it, right? So this one is a kind of like a hierarchical index. And then we can also try to converting this hierarchical index into the single index, like by using the unstack kind of function. If we can use this unstack method, key 2 gonna be the column right here, right? And then A, B, C, D, like a highest label gonna be still used as a kind of our row label. And then this one gonna be our single index data frame, right? So unstack function is quite useful when we get when we try to convert into the hierarchical index into the one simple data frame. And then also we can do that is the inverse operation is the stack. Stack means we can do the revert that process like this, right? This is how it works, okay? And then the other one is that we can also try to designating about the axis as a hierarchical index. So in here, like if we have this kind of a data set with the index for the multiple hierarchical index, and also we also have a multiple column index, right? In here, in the column name, we also have Ohio has the green and red, and Colorado has a green. So it also has the hierarchy, like a row in the column. Okay. So that's the kind of things that we can do. And then also we can designating the index name based on our column name category. Here is the state is Ohio and Colorado, and color is the green, red, and green, etc. Like this. Okay, based on it is the kind of based on the column. Okay. And then also we can using the n levels that actually give us about how many levels do we have as an indexing value structure. So it has the 2 means that we have a 2-level hierarchy of the hierarchical index. And then we can also frame and then extract some group of the data set with the Ohio category, like a green and red. And then we can get all of these values if we can do the frame kind of values. Okay. And also at the bottom, it is also the same for the arrays. So whenever we also have arrays, like a single arrays kind of data, we can also using that database in the same way, right? So Ohio, Colorado, green, green, red, green, and then our name is a state or color. So we can all the designating about the color name, and then try to making the array to do that. And then the second one is the reordering the sorting. So this one is kind of like how we can reorder our key. So rearranging our keys. So right now we have a key 1 and key 2 in this example. Like a key 2 has the numeric value, and then the key 1 is the lower value. Like by swap the label. So existing key 1 and key 2 hierarchy gonna be changed. Okay. And then the second one is the sort index is the label 1 means we also has a key 1 is actually label 0. Key 2 is actually label 1 in the index and database. And then this level 1 is that we can try to rearrange our data set based on this key value, keys 2 value. It is about the kind of like more like sorting or rearranging the database by using this level indexing number. And then the level 0 means that we actually using the key 1 as a factor, and then we can try to do these things like a state color and then a color green red and a color green silver. So now we actually have no understanding about how we can swap and manipulating our database by using some of the rearranging method. So now by using this data rearrangement method, we can also conducting what is called the summary statistics, like calculating the mean or median or mode, or maybe try to understand about the distribution of the data set, etc. So when you think about the group by, means we can also have a group by. Group is in the tidyverse in R, right? So we actually using the group function, use the group function a lot, because whenever we thinking about the grouping our table by using some specific key factors, and then we can also get to the functions. Okay, in here, like a sum is the method or functions. So whenever you group by this data set, you will have a somewhat wide, not wide, like a long data set, and then we can actually calculating what the sum data set is a function. So that's the outcome we can get about. Okay, like all of these numeric value has uh integrated, like a summarize in based on this key 1 and 2, key 2 indexing label like a 1 and 2. Because the original data actually has the A and B as a key 1. And then now we can try to summarize our data set based on the key 2 values, like a A1 and A1 or something. Okay. And also group by the color or by the column sum means we can actually try to aggregate by column. Okay. So next one, do you have any questions so far?
No, it's fine. It's quite fine.
Okay.
Mm.
So let's start with the indexing with the data frame column. Okay. So this one is a kind of okay. Now we have this kind of a data set, for example. Okay. So all this 0 to 6 is this one is a row label. And then the A, B, C, D is the column name, right? So when we try to do the set index means based on the C and D as a kind of a hierarchy, like a indexing, row indexing, route, no maybe value. So we can using the C as the most highest hierarchy, and this one is the lowest hierarchy, lower level. So C means actually we can try to do the 1 and 2, right? And then D is actually has a 1 and 0, 1 and 2 and 3, right? So in the one here is this value gonna be cleaned up. And then two under the two, like 0, 1, 2, 3 also has this kind of a summary statistical result. Okay. And then sometimes we can think about the removing the sum of the redundant column from the data frame. In that cases, we can try to drop true. It automatically drop off to about the dead columns, which does not belong to the another indexing outcomes. Like in here, set index C and D gonna be this one, and then drop false means we can only using the 0, 1, and 2 as a C, right? So those kind of things gonna be how we can work with the set index. And then a reset index is also kind of a good way, but the thing is the opposite way. Like whenever we have these reset indexes, there is a no C and D as a hierarchical indexing. Those C and D gonna be used as the normal column for the next step analysis. Okay. So now in the next section is a kind of a combining and then merging the data set. So in pandas, there is actually package method called merge, right? Actually, this merge function is everything about this 8.2. Okay. Because merge actually include involve the question about the how we can like a type of the merge, and then what's our outcome. These are the kind of a little bit important when we try to combining and merging the database. And then what's the criteria to join those data sets. So pandas merge has a lot of functions about how, and then show us about how we can merge the data set more efficiently and in an easy way. It is quite similar when you use the tidyverse packages in R. Okay. So database style data frame is by using the merge function. Like if we have a DPF1 has this data and then a DF2 has this data. We don't have to worry about how many rows in that table each has. But the thing is, we actually try to identify which one can be used about the identifier for the joining or merging this data frame. Okay. So when we try to merge this one, we can actually try to merge the left join. Left join means if we have a value, and then if we have a B value, left join means this value only. Okay. And then next one is we can also using the merging the two data set based on if they have a same key on the data frame like these two. And then we can try to use the merge method. And then also another argument is the key. Right? So that's how merge works. And then also we can try to think about okay, now if we have same key factors, but the thing is the left table and right table key index column name is different. That also does not have to worry about it. So the only thing we have to do is under the merge function, we can actually designating about which variable in each data set we have to use to combine both of them together. Okay. So in here, when we using this panda merge function, it actually has the inner join or left join kind of functions. But the thing is, we also have a left and right and outer functions. Like when we say about the left means like this one is a A and B. Left means we only have a left value, unique left value only. And then a right one is just kind of a right one, right? And then outer means is we only choose the outside of our boundary, not boundary of the maybe in here in these things is more like a kind of a inner join. So and then the outer join means kind of except for this inner join, the other part of the section gonna be the outer join, not the overlapping. So that's the how argument is used. And then we can combine these things by outer, and then here is the result. So no overlapping zone, except for the no overlapping zone, we can only extract all of these non-overlapping area for the outer zone. Okay, this one is the left, this one is the right. And then actually in R, there is actually one function called, this one is actually full join. And then also another one, last one is this is inner. Like left is this, right is this. Okay. Any question? This is how it merges about. So once you can understand about this kind of a Venn diagram about the join and merge. Now you can understand, you can already done with understanding the how you can join in all the data set for uh the data frame in Python. Okay. So do you have some problem with the internet right now? Can you hear me? Okay. Okay, I keep going. Okay. So as you can see in the table in here, you can see that there is a how you can try to using the merge. Yeah, you are right. Because in Python, we also in the base R, like a R, in the base R, we actually have a merge. And then also when we try to use the tidyverse in R, we actually use the left join, right join, etc. Right? And then in merge is actually in the merge function in R also quite similar to the merge function in Python. So you can just easy to compare to the what's the common thing and what's the similar one, similar to both languages, or what's the difference. And then in here, if we have this df1 and then a df2 data set, and then we can, using the merge function, we can do the based on this key as a join ID identifier, and then how is the left means we actually join the df2 into the df1, like df, like for example, if we have a df1 and df2 in this case, left join is this, right? This part is the left join, right? And then the next one is the kind of an inner join in here is like I said, inner join is we only get this kind of data, all of them. Okay. And then we can also using the merge key, even if we have a different key, different key name in this case. And then how we can designating how we can join that one. Even if we have a different key column name, we can also join our data frame into one. Okay. And then also like here, what this one is about is the way if we have a same key variable, same column name into the both column, that means if we have underscore x and y kind of those name gonna be the added to the as a new column name, because to avoid about the overlapping, right? So sometimes we have a overlapping column name into the both table. If we can try to join the both table together, we will have this kind of name structure because of the two differentiating about those two column name. Maybe if you can try to treat those columns separately, like a different name, like a customizing those naming structure. You can also designating about the surfaces right here. And then you can try to do the first one gonna be the left, and then the second one gonna be the right. That actually allows you to identify which column gonna be where each column gonna come from. Okay, that's how it works. Yeah, it's a very straightforward when you're looking at this example. And then when you're looking at these pandas, all of these things are the functions you can use, like a right or on, or left on, right on, or joining by using the index. And then a surfaces is also very key one. And then a sort is also very useful. And then also when we try to merging the index like this, and then a left and right table, and then when we try to merge based on these key value, and then right index is the true in this case, you can actually keep it based by using these two row name and key column as a kind of a joining key variable, and then you can using these row labels as a kind of a key index variable to join. Okay, because in this case is the left table actually has the separate column as a key variable, but in the right column, right table, actually row label actually has the key index. In this case, by using the right index equal true, you can actually designating about where the index key variable is in that right table. And then by that way, you can actually join these two tables together. Okay, same thing in here, like a left on the key, like here, and then right index is true means this right table row label gonna be used as a key index variable to join. Okay. Yeah. And also in this one is also the same thing. Like in here, in the left one, table has the key 1 and key 2. So that means a separate column. But the thing is, when you're looking at the right table, you can using all of these hierarchical index as a row column, row label. You can using this one as a key, and then you can also using these two as a key, and then join this table together based on these two keys, two key area, and then you can merging those variable like this, like right index is true, so this, and then the right index is true, and then the left one is a key one and key two means this, right? So that's how it works. Okay. So now we just keep trying to looking at about what's the kind of a different type of the merging situation or conditions we can have, and then each conditions or each problem, how we can combine those two tables into one table. Okay. And then in here you can also find out the both index can be used as a key variable. So in this case, like in the previous one, in the left table actually has this row label as a key, and then second one is also the same here. The right table is the row index is the key. So we can actually using the both index as a key variable to joining it. Okay. And then the rest of these things is about how we can try to simplify the merging by the index. Actually, other than the merge, in Python there is also a function called the left join command, like this, like a join command here. So this join command is also the pretty straightforward kind of argument. So join left table and join, and then you can designate the right table, and then you can try to define the what kind of a join type you can do. Also the same thing, you can also designate about the key by using this join method rather than using the pandas. So in this case, we can using the merge to join the table, but also the join method in Python can be useful when you try to thinking about how you can combine the both table into the one big table. Okay. So in here, you can, when you say there is another data frame you have, like New York and Oregon, and then in the left two table, and then a dot join method here, and then you can designating about the right table to join, and then another is another table. So it's more like a kind of a multiple join, like a 3 table join. Okay, so it's a more than 2 table. So you have a left table, and then a right table, and then another table, right, and another table gonna be joined to the left 2 table. This is how you can get about the outcome. Okay, and then you can also designating about how you can joining the joining type, like outer join or inner join, or maybe left join, right join, etc. Okay, so the last example is kind of show you about if you have more than 3 plus tables to join, it is still possible to do that. like if you have a left 2 table, and then a right, and then another, and then you can just keep joining this table into the left 2 table, and then this you can get that left 2 table with the right and another table data in it. Okay, that's how it works. So actually, in fact, this is about the half of the chapter 8, and then the rest of the part is kind of how we can concatenating, and then how we can combine, and then the pivoting and reshaping the table, which takes a little bit longer time. So maybe I think that I'm gonna stop here for today, because also your internet is not that good. So I just stop here for now. So today we just try to looking at how we can merge the both table into the one table, and then what kind of a situations, or what kind of a data table type we can, depending on the various type variety of the different type of the table, how we can combine those different types of the table into the one big table by using the Python, or by using the pandas merge method or join method. Okay, so today we're gonna cover the merge, and then we just looking at how we can, depending on the different type of the table structure, how we can combine all of these table together. Okay.
Yeah.